All right, we're back up. The part two. I don't know why the internet is just not working earlier. I restarted. All right, let's continue. So if it's even value, so we're gonna say self.bst.query, right? I'm gonna query self.bst.count divided by 2. Let me see if we have to go plus 1. 3 divided by 2 is 1, which is actually it's the second one, right? So it's the nth, it's the first, it's second. So we have the plus 1, I think. I have the plus 1. It's 5 divided by 2 is going to be 2, but we are looking for 1, 2, 3, the third one. Yeah, so that's that. Otherwise, we're going to say that's going to be bst.query self.bst.count divided by 2, like 4 divided by 2 is 2. So if we say 1, 2, and plus 1, right? Plus 1. So basically the same thing here. Query, same thing, but this is going to be divided by 2. Let's just call it n. I do not like to write this self.bst.count so many times. All right, it's going to be n, and n equals self.bst.count divided by 2. No, without count. And we do this, and this going to be query plus 1. So query myself and query plus 1 and divided by 2. And I think I forgot the parentheses. Yeah. And this one needs parentheses as well. All right, let's see if this solution will work. So basically, use a BST to simulate the whole situation. Yeah, I'm not really confident that BST feels, especially the traverse, feels iffy. All right, let's see what we get. I run the code. Oh, what the hell? Oh, indeed. What the hell, man? Come on. I'm not supposed to have this. Query, yep. Try again. Unsupported tuple and int. Oh, yeah, I should not return traverse because the traverse return 2 and a current remain. So we should return 0, right? Tuple, we only need this first one. All right, try again. Pending, finished. All right, so far so good. Let's try some edge case. So let's do 1 add and 1 find, right? So 1 add and 1 find. So 1 add and 1 find. All right, let's see how this one goes. Okay, try it. Pending. Runtime error. Add, find median. Hold a sec. So we add 2 zeros. Oh, this one. Oh wait, this one shall be able to handle 2 zeros too. We add 0 and we add a 0. That should be added to the left branch, right? And then we call find. N is 2. So we're going to return plus and plus. N divided by 2 is 1. So for the first one, I found the second one. So we found the first one. Let's try to see query. N equals 1. So we go 1. Right? Remains 1. And no, we go here. Right, what's the problem? The problem is I don't know. What's the problem? They should return 2 values. One, if current remain, we go traverse dot left, so we go left, and we do go left, and now we're in the left. We have if node, if not node, no, we have node, and now we go this return. Okay, so we now current if remain, we have remain, and remain is 1. The overall remain is 1, right? Then we return node dot value, which is 0 and 0, and we go back to the previous level, which is this 0, return val 0 0. So we shall have the right one, right? This one should be good. And this is 2, right? This is 2, so we go here, here, and then that remains 2. Now, so we go to the right and return 1. Right, should be none 1. Going back to this, and I think this none and 1, right? That's after the left traversal. And if remain is 1, and we check if remain, oh, but maybe it should be current remain. Yeah, I think this should be current remain, right? It's current remain. So after the left traversal, yeah, I think it's the current remain. If current remain is 1, then I return this. If not, I think it's the current remain minus 1. Alright, let's try run this case. Fail this case. Let's try this case first to see if it still works. Yeah, it still works. Try this case. Well, this case now works. But earlier, why would it not work? I think because unsupported none type. I return none. That makes sense. Okay, pending, judging. Ooh. Nope. Nope. That's not the solution. I know it must be something that's like that's sorted or something like that. No, that's not a. It has to be balanced. It cannot be like this unbalanced tree. All right, I'm gonna check the solution. I don't know, but I'll be back. All right, I'm back. I'm ready to check the solution, but I still kind of want to see. All right, this one, this naive BST TLE. Did we pass anything? Oh, we passed actually 16. Huh. Not too bad. Okay. How about monotonic stack? Will that help in our case? And we get a value, get another value, and then we just say monotonic increase. I don't know. I don't think monotonic will work. I mean, the thing is very simple, right? We have like unsorted or sorted but currently in the list, and we need to You know what? Actually, maybe this one can be improved. That's one query, right? And this is like these two queries shall be able to combine. Right? So think about it. If we can combine these two queries, then we only need to do it once. This now we do it twice, and a lot of it is repeated. So in that case, if given any value, we return this value and a value before it. Now let's check. Let's get some. I shouldn't say check. Let's get some intuition. Right? Let's get some intuition. Like what type of solution that we can try to. Yeah, I think I've done this before. Yep. Yeah, 2019. I've done it before, and I even sorted solved it myself. CPP is this. What was the method? Heap sorting 2 pointers, a priority queue. A priority queue. I have a stream coming in, right? I have a string coming in. I mean, yes, priority queue can always tell me the current. I don't need it to tell me the current biggest, the current smallest. Hold on. I might stumble on something. We want the median value, right? Let's write it out. So we'll get some value in. We'll get a value. We'll get another value. Right? That's 2 values. That's easy. 1 value. That's easy. 3 values. What if we have another value coming in? Let's say that value, if a new value coming in is bigger, right? If it's bigger than my current value, my current max value, right? If coming in a new value that's bigger than my current max value, then, because the median, if you think about median, right, it shifts if we're constantly adding new values into it. Like if we're constantly adding larger and larger value, then it shifts. But if we say we have 1, right, and then we add a 2, that will shift a little bit, and then we add a 0, that shift back to 1. We add a 3, it shifts. We add a -1, and then it shifts back. So it shifts back and forth, right? Which means if we add a value, if we add a value that's large than everybody else, are you saying we don't have to add it, actually add it? I don't know. Man, I was able to solve it. I feel like I was able to solve it in my first shot back in 2019. I don't have any clue right now. Like, what are we tracking as we're going through? We're tracking the median. If a new value comes in, and that's a large value, it's larger than everybody else, what's going to happen? Or if it's not larger than anybody else, right? I mean, it doesn't really matter. Like if we're given a string of values, right? Let's say we have 5 values and they're sorted. And we'll have a new value coming in. If the new value is larger than the previous median, right? If it's larger than the previous median, then the median will shift. That will be the median will be the average of current one and the new one, right? And then if we add a value that's smaller, then it shifts to the lower side. Right? No matter where I add it, it's going to be shifted to the lower side. So if I know the 3 values, right, then with a new value coming in, it's in between these two, then I swap this. If it's larger, then I don't move. Or if it's larger again, then you have to move. No. That's not the way to go. We can find the k smallest value by using a heap, or k largest value using a heap, right? K smallest and a k largest. So we have a heap, and now have a new value coming in, right? And we can push it into it, right? And then if we want to track the k largest, and then we just add it and then pop it, right? And then we want to track the k smallest, the same thing, we add it and then pop it. So there will be the k. So if we have basically, we just divide this stream into 2 data structures, right? 2 heap. One heap gonna track the maximum value, and the other heap track the mean value, right? And then the median shall be the values in the middle. How do we do the values in the middle? It's like this should be a max heap, but it's like the max value, like the kth maximum value. The kth maximum value and a k plus 1 maximum value. Yeah, it is the kth maximum value in the heap, right? Just the k has to change. Like if my current has 5, right? Then now what I want to find is the 3rd max value. If I'm 6, then I want to find the 3rd max value and the 4th maximum value. So what we always do is we add a new value, right? So the k, so the length of the heap, it's going to be a maximum heap, right? And the length, but that will shift towards, that's the k max, right? That's the k max. We'll shift towards the max. What we want is in the I know the min is the k. Okay, so we do a min, not max heap, a min heap, right? It's gonna be a min heap, and we keep the k smallest value, and we use a max call in this main heap, inside the main heap, because what we want is the maximum value of the main heap. Yeah, and the size of the heap is going to be what? Size of the heap. Well, the size of the heap is going to be, has to be slightly bigger, right? So if it's a 5, we need to keep 3, right? If it's a 6, we need to keep 4, because we need 3 and 4, the third and the fourth. So we need to keep 4, which means we're going to do the length, the count, divided by 2 plus 1. We need to keep that many values in the heap, and if count is an odd value, then the max value is the median. If count is an even value, then we need to get the max and the second max, right, for the two values. But that can be done within one traverse. We can get the max value and the second maximum value, right? We can get that. Let's try this idea. I mean, well, count as hint, but it's not a real. But I really want to see what I did in the past. I cannot figure it out right now. All right, so this is another shot. Oh shoot! Of our effort number 3, and this one we need from import heap queue. Right, so we need a heap. So this one is going to be heap, right? Equals heap is going to be this, right? And self dot k equals 0, right? And we add number, right? We add number. What we do is heap q dot heap push. We always push into the heap first. Heap and push number in, right? And then self dot k equals what? Equals what? Actually, let's not do self dot k. This is just going to be n, right? So n plus equal 1, right? And then we're going to check for the heap size. It's a main heap. It's a main heap, so we say heap size is going to be self.n divided by 2 plus 1, right? So we say if len self.heap is larger than self.n divided by 2 plus 1, right? Then self heap q dot heap pop self dot heap. Otherwise, we don't do anything, right? Let's add. Now, when we find, we're going to say n equals, that's basically self dot n, right? So we say if self dot n divided by 2, it's a odd value, then the size is the one we want, right? So we say divide by 2 plus 1, which is going to return max self dot heap, right? Otherwise, we need to find the max and the second max, right? We need to find the max and second max. So how do we find the second max? We just traverse. We have to traverse through. Each time it's going to be O n if we traverse through. It's better than O n log n. Add is going to be log n. Find is going to be O n. I'm not sure, man. I'm not sure. So say um, h2 is equal to max self.hp. Let's put it here. H2 if it's this, which will return h2. Otherwise, I'm going to say for h in self.heap, right? It's a main heap. I know the min, I don't know the max. Unless we turn that into a max heap. But that is going, no. No, we cannot. But can we? We maintain a max heap. We're pushing a value. Hold on. And we pop it, right? So which means it's a min heap, right? So if it's a min heap that we pop, we'll go to min value pop. No, this is going to be a, this will pop in the minimum value. It will contain is all the maximum values. Oh, it's fine. It's fine. This is all the maximum values. Oh, that's not, it's all the maximum values. So the k maximum values, I don't like to consider it like that. K maximum values, I don't feel comfortable because I've been thinking in the k minimum. So well, same thing, just push a negative. No harm done, right? Yeah, we just push a negative. So this is gonna be a negative. So that's the max. This is the main heap, so I'll get a max value. If this, I'm gonna return this. Otherwise, we're gonna say if for h in this, all right? For h in this, h1, let's say h1, hold on. h1 is going to equal to a very small value, very small value. So h1 is equal to, let's say, self.hp 0. All right. Hold on. What are you doing? It's gonna be a coming in. Yeah, it's a min. It's a large value. Is that a min heap? No, it keeps. Hold on. No. It naturally is a min heap. It naturally is a min heap. Yeah, so it naturally is a min. Hold on, I got confused. It naturally is a min heap. So on the top is going to be the min, right? So if every time I come in a new value and I pop, every time I come in a new value, if it's more, then I pop the min. What's that going to do to us? What I want is to keep the k minimum value in the given thing, right? Which means if I get something big, I want to pop it. So you want a max heap, right? You want a max heap. So every time, yeah, I want a max heap. That's why I have to do this. I want a max heap. I want a max heap. Therefore, every time something big, it'll be popped out. Something big, it'll be popped out. So that's a max heap. Right, that is a max heap, which means what we kept is the minimum values, right? So we kept is the minimum values inside. That's a max heap, right? Max heap. And the top, at the top, right, is the min value. The top is actually the max value. So we can get the max value. Oh, we immediately get the max value. The max value is just minus self.hp 0. on the top, that is the max value. That immediately is the max value. Because it's a min, because it's a max heap, right? It's a max heap. I'm keeping a max heap. So the top is always the maximum value, but we have to negative it, right? So that's the max. It's a max heap. So we get a max. Oh, it would be simple. So we just, yeah, we don't have to do that. So if it's even, if it's odd, then return this. If it's even, right, we're gonna say let's say first max equals minus self dot HP, right? And then this is going to be first max, which is the actual max. And then I'm going to say second max equals well, now we're going to say heap q dot heap pop, right? Dot HP, and then second max equals minus self dot HP 0, right? And then we have this, then heap q dot heap push, right? First max. So we just want a second max. So we pop the first and push the first again. So both are log n, and the result is going to be first max plus second max divided by 2. All right, let's try this one. So this one is heap based. All right, let's run it. Heap push. I need 2 self.hp. Do we use n? Yeah, we use n here. Yeah, that's larger than this, then we pop. All right, try it again. Not correct on the second call. Shall return 1? No, our output is 1. It shall be 2. All right, let's see. So 1, 2, 3, right? So push 1 in. Push 1 in. So actually it's minus 1 because pushed in. And let's just remember we're doing a max heap. Right? So self.n equals 1. Len HP is 1. 1 larger than no. So that's currently we have 1. And now we're pushing 2. So 2 pushing in. So 2. Right? So 2 pushing in. And self.n equals 2. And then 2 divided by 2 is 1. 1 plus 1 is 2. And then self.len is 2. So we have 1 and 2. Yeah, now we have 1 and 2. Now I want to find median, right? I want to find median. Now self.n is 2. So it's going to be pop self.hp, which the max could pop, so 2 gets popped. So second max is 1, and we're gonna push. This one minus, because this I take the minus. All right, let's try again. Yep, do we dare? Let's try it. Wrong answer. That is not promising. All right, let's take a look at this one. I have a wrong answer. Yeah, debugging has to be done here because I don't want to do debugging over there. All right, let's see. Where did we get wrong? Diff happens here and it's starting to drift. Right, it's starting to drift. So 1 is correct, 2 is correct, 3 is correct, 4 is not correct. All right, we just keep going. So 1, 2 is getting 1 and 2 in. All right. Now we're pushing 3. So 3 pushing in. So we have 3 in it. So we have 3. And then self.n is 3. 3 divided by 2. What's 3 divided by 2? That's 1. 1 plus 1 is 2. But currently, self.hp is 3. So it's larger, so I'm going to pop. So 3 gets popped. Yeah, 3 gets popped. Now 4 comes in. 4 comes in. 4 gets popped as well. No, 4 does not get popped because 4 comes in. When 4 comes in, the length is correct because this is going to be self.n is 4, right? So we need 3. Our current is 3, so we don't do anything. So now it becomes 1, 2, and 4. But that's not what we want, right? That's not what we want. We want a 1, 2, and 3, right? So what we want is when we have 1, 2, 3 in it, we want 1, 2. Yeah. But 1, 2, 3, 4 in it, we want 1, 2, 3. How is that going to work? I don't think that's going to work. Huh. How about 2 heaps, right? 1 heap is a max heap with size what? Max heap with size. Ding, 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 ding. Doesn't matter, right? Let's say with size n divided by 2. And so that's the max heap. So max heap, we have n divided by 2. We also maintain a main heap, right? Main heap is going to be n divided by 2 as well. But what if we have an odd number? So 1 has to be n divided by 2 plus 1. Right, 1 has to be that. So let's say our max heap is n divided by 2 plus 1. But that we already see the problem. It's n divided by 2 plus 1. We already see the problem. Because I have 1, 2, right? And then 3 comes in, right? If we go 1, 2, 3, and I keep this, can we also keep the middle number too? Because if we want to keep the middle 2, right, now is 3. 3 divided by 2 plus 1 equals 2. So in 1, 2, 3, we do want to keep the first 2. And in that case, we discard 3. But now when 4 comes in, now we have a trouble. If we have two heap, a max heap and a min heap. So the max heap will keep the first n divided by 2 values, right? And the min heap will keep the maximum n divided by 2 values. And we have the min value from the min heap and the max value from the max heap. And if it's even number, so it's going to be the average of these 2 values. If it's an odd number, we do need to keep one more value in here. So when a new value in, if it gets pushed out from the max heap, right? So it'll be like this. We got a value. We put in the max heap, right? And if it's too much, I'll get a value popped out, right? And then we're gonna put that value popped out, push into the min heap, and then something might have popped out as well. So we just do this exchange, right? We do this exchange, which means if my value is in between, I'll get popped out by both, right? The min heap, I'll get popped out by both. Yeah, if I belong to one side, right? If I belong to one side and the other one. Yeah, I feel like that is the key. That is, so we're gonna have a main heap, and let's just call it main HP, and self.max heap. So we have two, we have n, and also we need a self.mid. Yeah, doesn't matter, we'll just set it to 0. We actually need to set it to, what value do I set it to? The mid. Don't worry, don't worry. So let's set it to none, because I don't know what it's going to set it to. So add a value, right? So we first add to this one will go first, right? Now we're going to push to min heap first. Right, we push it to main heap, and we say if the main heap size is larger than self.divided by 2, right? Then we say mid equals, actually self.mid equals minus pop main heap, right? After that, we're going to say heap q dot heap push self dot max heap self dot mid, right? Because max heap is, I got it wrong. This is the max heap. Yeah, this is the max heap. This is the max heap. Keep the min values. That's the twist. The max heap, keep the min value. And this is going to be the min heap. That's why I can push myself. So I'm pushing here. And if len self dot min heap is larger than self dot n divided by 2, right? Then self dot mid equals minus, no, just heap q dot heap pop self dot min heap, right? And of course, if one of them is not, that means n must be an even number. Then I don't need a mid. Does that make sense? I mean, at the beginning, right? We're just trying to think at the beginning. We push one value in, and 1 divided by 2 is 0. So self.mid is the value that I pushed in, and I pushed to the max, to the main heap, and again self.mid gets popped out. So we have self.mid is the original value, and then both is going to be none. That's after the first push, right? That's after the first push. So here is if this returns self.mid, otherwise I'm going to return self.main heap, right? Main heap 0, right? Plus, actually minus self.max heap 0 divided by 2. If I push another one in, and oh, it will get kept. If I push another one in, if I push like 1, right? So self.mid is 1. If I push 2 in, I will try to push here, and after I push here, then self.max heap is not larger, right? Max heap is not larger. Max heap is not larger because max heap, I just put -2 into the into the max heap. -2 into the max heap. Yeah, I feel a bit iffy in this. It's a little bit weird. Because then the max heap, which is on the left side, right? Max heap will have -2, and the min heap will have -1 because I push the mid into the min heap, and the main heap will hold it as well. Now we have -2 on the max heap and 1 on the min heap, and it will pass. All right, this will pass, but that's not what I want. I wanted this the reverse. I want -1 is on the max heap, right? And 2 is on the min heap. That's what I want. So when you push, which value do you push? I mean, it depends, right? It depends because I have a mid value and I have a number. If number is bigger than the mid value, right, then I push the right side. If the number is smaller, then I push the left side, right? I think that is the thing, and hold on. So if it's larger than mid, I push to the right side. Yeah, we can see, right? We can see that if the current n plus 1, right? N plus 1. If n plus 1 is going to be an odd value, like we'll do this, now current n is going to be the odd value, which means previously is an even value. If it's an even value, we have both heap fully occupied. And in that case, we don't have a mid. So we do this. This will work, right? This will work. But if the previous one, so here's the deal, right? We're going to do this, and we're going to say if self.n divided by 2, mod 2, right? If self n mod 2 is an odd number, then we do this, right? We have to push the number, but we can actually do better. We can do better. We can check, right? We can check. We can just say if num, right? If num is let's say larger than self.main heap 0. So the number is larger than the smallest on the right side, right? If it's that, then what if it's equal? Yeah, we can do equal. Let's just do equal. If it's larger or equal to, right, then self.mid equal to heap q dot, I think we have a push pop, right? We have a push pop self dot min heap num. So basically I say push the num into it and then pop the smallest. That is going to be the mid, right? So that's that. Else, then self.mid push pop, there's going to be the max heap, right? On max heap, I'm going to have to push minus num into it, right? Minus num into it, and a maximum pop out to the negative value. So that's that, which means we just create a mid, right? Else, if it's even, right? If it's even, then previous is have a mid, right? Previous we have a mid, we have a left, we have a right. Now the question is, where do I put the previous mid and the current value, right? Basically that's the thing. So one has to go somewhere, right? Somewhere. So we know the mid is in between the two, right? In between the two. Therefore, the mid can go either way. But now the question is the new value, right? If the new value is larger than the mid, then mid goes to the left, the new value goes to the right. If the new value is smaller, yeah, that's become, if num is larger equal to self dot mid, right? If it's larger than self dot mid, then we just say heap q dot push, right? Self dot max heap is that on the left side. We're gonna push minus self dot mid and heap q dot push also self dot main heap num, right? I'm gonna push on this. Otherwise these two are gonna be reversed, right? So the max heap we're gonna push in num because num is smaller than the self dot mid, and the main heap is gonna push self dot mid. That's that. And afterwards, self dot mid we set to none, just to make sure that no confusion, right? And like that. Try it. Index out of range. Okay. Okay, it's the initial one, right? Yeah, it's the initial one. I would just say if self dot min heap, right? If self dot min heap and num is larger or equal to, I mean initially it was just gonna be self dot mid equals push and pop. That should be fine. And after the first one and the second one coming in is even number, so we're gonna go this way, which will get it, and then this one will not be checked again. Okay, try it again. Heap Q has no push pop. That does not make any sense. I remember it does have something called push pop. Heap push. Heap push pop. Okay, I think I got it all wrong. It's going to be heap push pop. Heap push pop. And there's no push. It's heap push. Oh my god. I should have copy and paste. Alright. Try it again. We got it this time. I have confidence. Submit. There we go. I think that is the solution. Yep, that is the solution. The heap solution. I mean, we got a hint. So that's what I'm gonna do. We did get a hint. Got a hint from the question about using heap. So this solution keeps two heaps. One max heap and one min heap. Both heap has size self.n divided by 2. The max heap helps to maintain the, let's call it n divided by 2, so not self. Right? And the n divided by 2 smallest values in the string, right? The min heap helps to maintain the n divided by 2 max biggest main values, smallest, biggest, largest values in the string. Thus, we can obtain the n divided by 2 right, n divided by 2 smallest value from self.max heap 0 and the n divided by 2 plus 1, I shouldn't say n divided by 2 largest value from self.main heap 0. This setup allows for very simple medium computation when n is even. We simply perform self.main heap 0 minus self.max heap 0 divided by 2. Note that we need to use negative self.max heap 0 because heap Q is a main heap. When n is odd, we need to find self.mid. All right, this can be found by what? By comparing the currently added value to the n divided by 2's largest value, right? If num, current added num, right? If num is larger than the n divided by 2's largest value, larger or equal to v, then self.mid must be the value popped by the main heap, by self.main heap after num is added to it. Otherwise, self.mid is the value popped by self.max heap after negative num is added to it. So each add num runs in O log n time, and each find median runs in O1. And this is the same runtime as the sorted container solution. Alrighty, that's the one. Alright, let's take a look what I did in the past. Did I just sort it? Oh, wow, I was able to get it in the first shot. Oh, percolate. What the hell? Percolating up, percolating down. Oh, I have to do it myself. Jeez. I am not able to write a heap by myself right now. Back then, I probably can't. It probably took him a long time to do this. Who knows? Oh my god. That is very, very complicated. But yeah, it's the same. So I was able to figure out, that's probably like an easier one, right? It's C++. Huh. Number before insertion. Wait, what is this? Multi-set. Oh, I think I was using, is it multi-set? Hold on. Sorted num.insert num. Size this. If size equals 1, low, mid, high, mid. What was I doing? If number is smaller than this, or number larger than this, and blah, blah, blah. Oh, I was looking for the pointer pointing to the middle two, probably because it's not possible to access it directly. Yeah, it's multi-set. Yeah, it's what's that called? It's sorted container. Multi-set is a sorted container. I think we just need to find, like, after this is like binary search? If num smaller than this and num larger than this, high, mid, minus, minus. Odd size before num insertion. Then high, medium, minus, minus. If num is larger than the low median, or the num is smaller and num is smaller than high median. Hold on. So odd size before. Odd size before. So low and high. Isn't it pointing to the same place? No, I think no. I think low is pointing to the place. High is always high. Right? Therefore, if num is smaller than high, but larger than low, then high minus minus. That's true. If num is smaller than low, then high and low both minus minus. That's true. What if num is larger than high? If num is larger than high, oh, then we don't change. That's true. I know what this is trying to do. Now, this is sorted container. This is sorted container. How about this one? No, I think this, yeah, this is the same one. I think I just run a couple. How about this? Sorted containers. Oh wait, this is the one I just submitted. Jeez. This is the one I just submitted. This one. Oh, this one already checked. $200. Yeah. Did you say, like, yeah, let's put it 200 milliseconds or 60% ranking. Yeah. I think mode is C, heap. Yeah, max heap, 2 heap. Ooh. I don't like this part, and then this is definitely looks easier. So we have small and large. Nice. Good touch, small and large. So both are max heap. Pushing small and large. No, this is a max heap on the left, min heap on the right. And if small is smaller than the large, then we push the large to the small. Although, so they're either equal, right? They're either equal, or so we always push for the small, right? And small gets bigger, right? Small gets bigger, and then we push it to the large, and small gets smaller. And then we always keep the small, yeah, because to get a mid, right? I mean, it's fine. We can get a mid to say minus small divided by 2. That's true. So the small always hold. If small is a little smaller than large, then we move, then the 2 is the same, right? Or small, we go here, is larger than the large. Like if both are the same size, right? And we're coming in, small gets bigger, and then small can push to the large, and large push it back to small. So small is always 1 bigger than large. Can we like not do that? We get a small, right? And then, so we always add small, and we'll pop some small to the large. So we add 1 to the small, pop 1 small to the large. Then the small will not grow, right? The small not, then we add 1, we pop 1, we add 1, we pop 1. Now we add 1, we pop 1, right? And if it's imbalanced, we always push it back. Nice. One for the top half, and the other for down half. Keep 2 heap of size n. If we have outside, we'll keep size of the small heap n plus 1. Always put it to small heap, and then normalize our heap. Remove the biggest element from the small heap and put it in the large one. We can be sure that we have the property that the largest element in small heap is smaller than a smaller element. That's true. However, after this step, we have n elements. If we only have n plus 1, we need to put 1 element from the large to the small. Very good. Very, very good. I mean, there's no point in writing it again. Now, there's a point. There is a point. There is a point. So, 4, right? Same solution as the one above, with 2 heaps, but with better implementation. Right? It's always like that. Better implementation. Reference. Okay, the reference. So it's very simple. So we just call 2 heaps. Self. Yeah, I like what he called self.small, self.big, right? It's much easier. Then we don't have to even check the number. So just add num, self num int, right? So what we do, we just say heap q dot heap push, always push to the small one first, dot small minus num. The small is a max heap, right? So small is a max heap, big is a min heap. So I do that, and then heap q dot heap push self.big minus heap q.heap pop self.small. Right? So this guarantees that the biggest value in the small is smaller than the smallest value of the big. But after that, yeah, we need to reorganize, because if we don't, then the small will never grow. So we say we always keep the small one bigger than the big. We say if len self.small is smaller than len self.big, then heap q dot heap push self.small minus heap q, so good, dot heap pop self dot big, right? So that's add. Now def find median self return float. So this one is going to be if, right, if len self dot small is equal to len self dot big, return self dot big minus self dot small divided by 2, right? Else return self dot small 0 with this negative value. Very, very concise. Love it. Try it. Let's see. Oh, that's not correct. I forgot the zeros. Yep. Nice. Very good. Very good solution. Maybe even faster. That's the same. But it's concise. I love the concisement. Alright, that's it. That's it for today. I mean, should I count as I have done it myself? No, it should be counted as a hint. It should be counted as a hint. Alright, that's it. See you guys tomorrow. Adios.